David, I don't think we can hear you if you're talking.
All right. Hello, everyone. Can you hear me okay? All right. So that's horrifying. So this is a seminar in computer science where you're about to hear me actually speak. So let's start that from the top. Hello, world. This is CS50, and this is one of our first seminars for the new year, this one on Python, the goal of which is to give everyone a taste of computer science, a taste of programming, and ultimately a taste of Python itself, all toward an end of seeing where you might take things from here. So whether you've programmed before or not programmed before, you are all welcome to join here today. And we have an amazing group of mentors, volunteers from around the world who have wonderfully offered to help answer questions both within Zoom's chat, but also within Ed, the URL for which you should have received from me via email the other day. In just a moment, I'll introduce you to our teacher today, CS50's own Brian Yu. But we like to start these seminars with a group photo of sorts. So if you'd like to join me in smiling and waving for a few long seconds, we'll go ahead and start taking a whole bunch of screenshots of folks smiling and waving. Suffice it to say, there's quite a few people in the participants window. So give us a moment to scroll through from left to right, the many, many faces. Feel free to keep waving. If you want to switch things up to the other hand, that's totally fine too. Perhaps make your favorite face. And if we take that screenshot at just the right moment, you'll perhaps end up just like this on the internet. Tara, how are we doing? Enough seconds? Few more seconds. Tara?
All good.
All right. Thank you all so much. So without further ado, allow me to introduce you to our teacher today, who not only teaches CS50's Introduction to Web Programming using Python and JavaScript, but also CS50's Introduction to Artificial Intelligence. CS50's own Brian Yu.
Thank you so much, David. Welcome, everyone, to CS50's New Year's seminars. Today, we'll be introducing programming in Python. So if you've never programmed before, today will be your opportunity to see what it's all about and to try it yourself to get some practice programming as well. While I'm talking and while I'm presenting some Python programming, definitely feel free to ask questions. If you haven't already found it, at the bottom of your Zoom window, you'll probably see a chat button. If you click on that chat button, you can interact with classmates. If you ask a question there, I'm keeping an eye on that and we'll try to answer as many questions as I can. And also, there's a great team of mentors who are here as well, and the mentors will be in the chat to help answer questions too. Of course, you can also post questions on Ed, which is the course's discussion forum for these seminars. And there will be a couple times throughout the day where I will actually stop talking and give you an opportunity to write some Python code of your own. And at that point, if you have questions about the code that you're writing, definitely post that to the Ed discussion forum, the link to which I just pasted into the chat. And the mentors who are here with us today will be able to help you as you work through your code and can help you to try and get it to work. A couple of other things before we begin. If you haven't already, be sure to create a GitHub account if you don't already have one. You can go to github.com/join, the URL to which I just pasted into the chat. That will just set you up with an account that you'll ultimately use to sign into a number of CS50's tools. And then what we're going to be spending most of our time with today is CS50 IDE, which you can get access to here at ide.cs50.io. This is a programming environment that will be introduced to you shortly, which is where you're going to be writing and running all of your code today. So go ahead and go to ide.cs50.io and sign in with your GitHub account. And then you'll be able to follow along as I'm working through some Python programs as well. If you run into any technical trouble today, you can definitely still stay with us. Just ask a question in the chat or post a question onto Ed, and the mentors here will be able to help you resolve it. But I would encourage you that as I'm writing code inside of my IDE, that you follow along as well in your IDE, just to get some practice writing this Python code as well. So with that, let's go ahead and dive right in, and I'll show you what I see when I open up CS50 IDE. And once you do, you should see something similar, something that looks like this. IDE stands for Integrated Development Environment. It's effectively a tool designed for writing and running code. And this particular tool happens to live in the cloud. So we're writing and running code in the cloud, and we're just doing this so everyone is going to be in a consistent environment, and so everyone will see the same thing. Over here on the left-hand side of the IDE is the file browser. This is where all of the files that you create inside of your IDE are ultimately going to go. Right now, if you, like me, haven't created any files in the IDE yet, you'll notice the left portion is empty. But over the course of today's seminar, we'll be adding plenty of files to this as well, so that you will be able to see and open up any of the programs that we're going to be working on writing today. In this top portion of the IDE, this is where you're going to be actually editing your text files. You'll be writing all of your code here. And then this bottom portion is what we call the terminal window. This is the part of the IDE where you can write commands that are ultimately going to be run on the IDE as well. And so we'll get to a chance to experience both of these. But let's go ahead and start with our very first program in Python. So if you're following along with me in CS50 IDE, you can go to the File menu in the IDE and click on the New File button. New File button will just give you a blank file. And I'm going to save this file by going to File, Save. And I'm going to call this file hello.py. This .py or .py extension is just a convention with Python programs. This is the programming language that we're introducing you to today. And .py just tells the computer that this is, in fact, a Python program that we're going to be writing here. So I'm calling my program hello.py. And now I'm going to start writing code in this programming language called Python. And perhaps the simplest of programs I could write looks like this. I'm going to write print, and then in parentheses, I'm going to write the words hello world in quotation marks. So just one line of code here, print, and then in parentheses, and then in quotation marks, the words hello world. And so this is a fairly straightforward program. And what it's going to do, as the first line might suggest, is it is going to print, in other words, display to the screen, the words hello world. And hello world's in quotation marks. That is the text that we want to print to the screen. And anytime we have text in quotation marks, in programming, we call that a string. A string is just a fancy word for a sequence of characters, something like words or sentences or paragraphs, for example. And the fact that we see hello world in quotation marks inside of these parentheses mean that hello world is an input to this function called print. A function in programming is just some piece of code that is performing some task. Print, in this case, is a function that's built into Python itself. And the print function accepts as input this string, hello world, which is the text that we would like to print. And so with that, we can try running our program now. How do we run the program? Well, in the top half of the IDE, this is where we were writing our code inside of this text editor. Down below, this is our terminal window. This is where we can now start to run this code as well. And so I'm going to run this program by typing the word Python. This is a program that's going to run our code that we just wrote. And then I'm going to have a space. And then after that, I'm going to specify the name of the file that I would like to run, which in this case is hello world, hello.py. That's the name of the file that I would like to run. And then once I've written that, I'm going to go ahead and press return. And what you'll see printed to the screen, if you've been following along, is you'll see these words, hello world, printed to the screen. And then you see this $sign appear again, which maybe looks a little bit strange. This $sign is what's known as the prompt. The prompt just means, all right, whatever program we just ran is done running. And now it's okay for you to write another command to run if we want to run another Python program, for example. So anytime you see that $sign, that tells you your program's done, and you can run another program now if you would like to. So I'll pause here and give you an opportunity to follow along if you've been following along, and see if there are any questions that anyone has about anything that we've done so far. All right, I see a question from Anurag who's asking, do I need to include a semicolon at the end of this line on line 1? If you come from programming in another programming language, maybe you've experienced a little bit of programming in C or Java. In other programming languages, sometimes that semicolon is required. That is not the case in Python. Every language has slightly different syntax, works a little bit differently. In Python, you don't need to include a semicolon at the end of the line. Python figures out where the end of the statement is going to be for you, so you don't need to worry about adding semicolons as well. Other questions about anything else here? All right, well, with that in mind, let's go ahead now and try to write another program, something a little bit more interesting. I introduced you to one function already, which is this function called print that displays text to the screen. It turns out there are a number of other built-in functions into Python, functions that are just part of Python that we can use. And just as there's a function for printing something to the screen, displaying something to the user, which is the print function, there's also a function to get input from the user. If we want the user, whoever's running our program, to be able to provide us with some information as well. And that function is called the input function. And so here's how that works. I'm going to create a new file to create a brand new Python program. I'm going to call this program greet.py. Remember again, that .py extension just tells us that this is in fact a Python program. And now inside of greet.py, instead of running the print function, I'm going to run the input function. So I'm going to run the input function. And just as was the case with the print function, it takes parentheses, and inside the parentheses go the input to the input function. And what I'm going to say is I'm going to ask a question, something like, what's your name? Inside of quotation marks. This again is a string, some text. And what this line of code is going to do is it is going to ask the user to type in their name by asking, what's your name? And then the computer is going to prompt the user to type in some input. So let's go ahead and give that a try. Down here in the terminal window, I'll run Python, followed by the name of the file, greet.py. I'll press return. And now what you'll see is that my program is asking the user, what's your name? And notice that I included a space after the question mark on line 1 here, just to create a space between where the text is and where the user is going to start typing. So Emanuela, who's asking about that now, it's not required, but often it's nice from a user interface perspective for it just to be there for a little bit of visual space. But now I can type in my name. I can type in Brian, for example, and press return. And now I see this prompt again, which means the program's over. And that's all the program's doing. It's asking a question, what's your name? Then it's pausing and letting the user type in whatever their name is. So with that in mind, let's now try to do something with whatever it is the user's typing in. I'd like to, right now we're asking the user for their name, but we're not using that name later in the program. We're not doing anything meaningful with whatever the user provides as input. Let's try and create a simple program that greets the user. If I say my name is Brian, I want my program to be able to say, hello, Brian, for example. So how can I do that? Well, the first thing I need to do is somehow store or keep track of whatever it is the user types in. If we're asking a question like, what's your name? And I type in my name, I want my program to store or keep track of whatever it is that my name is. And to do that, we're going to introduce a new concept in programming, which is the concept of a variable. A variable you can think of as just some container inside of your program that can store information. And in this case, the information we're storing is whatever the user's name is. And you, the programmer, get to decide what variables your program has and what you're going to call those variables. And because the user is typing in their name, I'm just going to call this variable name. So watch how I modify line 1 here. I'm going to say name equals, and then the input. So what's going on here? Here I'm creating a variable called name. And I could call this variable whatever I want. I get to choose what the variable is called, but I'm calling it name because it's the user's name. After that is an equal sign saying this is what I want name to be equal to. This is called the assignment operator in Python. And we're assigning something to a variable. And here's what we're assigning. It's whatever the user provides as input. So the user is going to type in some input, and whatever the user types in, we're going to store that inside of this variable called name. And now down below, let's add some more lines of code. We don't just need to have one line of code in our program. We can have multiple lines of code, and Python is going to run our code top to bottom, one line at a time. So let's here print out hello, for example, and then a comma maybe. And now on line 3, I'm going to print name, where here name is not in quotation marks. That would print the literal word name, which isn't what I want. Here I'm just printing name, which is the variable that I created on line 1. I created this variable, and then down below here on line 3, I'm printing out whatever the contents of that variable happens to be. So let's give it another try. This updated program. I'm running Python greet.py. The program asks, what's your name? I type in my name, and it says, hello, Brian. So we've taken the information provided by the user, we're storing it inside of a variable, and then we're using that information later on in the program when we say hello. So I'll pause and give you a moment to try writing that and give it a try. A few people who have programmed in C are asking about the types of these variables, that if you've programmed in a language like C before, you might have had to specify that this type is an integer or that type is a character. And you have, when you create the variable for the first time or declare that variable for the first time, you need to include that type. In Python, it's not necessary. In Python, we can just specify the name of the variable, and Python is going to figure out what type that variable should be. All right, a few other people are asking about this user interface decision at the end, this experience, where we're saying hello, Brian, but it's hello, comma, and then a new line, and then my name, which feels a little bit strange. I probably don't want that. I probably want it all to be on one line, just hello, Brian. But before we get there, why is it that this is happening? Why is it that when it's saying hello, Brian, why is there suddenly a new line here? I haven't explained it just yet, but does anyone have a guess? Yeah, I like Liam's suggestion that I have two print functions here, and that's probably has to do with it. And what's actually happening is that Python, when it gets to a print function, it's going to print out whatever the print function says to print out. And at the very end of the print function, Python is automatically just going to add a new line at the end of the print. And that's just part of the print function because it assumes if you're printing something, maybe you want a new line to come at the end of it. It turns out that there are ways we can override that, and we'll get to that soon. But for now, I'm going to keep things simple. It turns out functions in Python don't just have to take one argument or one input, so to speak. They can accept multiple inputs if they're separated by a comma. And so here's what I'm going to say. I'm going to get rid of line 3, where we're just printing the variable name. And instead, here on line 2, we're printing the word hello. And after the quotation mark that ends the string and right before the closing parenthesis, I'm going to add a comma and then provide a second input to the print function, which is just this word name. And so there's two inputs now to the print function. They're separated by a comma. But what I'm saying is first print hello, and then also print this variable called name. And so now if I try this, what's your name? I'll type in my name, Brian, and it says hello, Brian. Great. If I try it with a different name, like David, then the program changes. It behaves a little bit differently. Now it's saying, hello, David. And of course, you could try writing your own name here too, and you would be able to see that as well. Keela is asking, how do you run a program in the terminal? The way you run any Python program in the terminal is by typing the word Python, then a space, and then the name of the file that you want to run. So if you're running greet.py, I would type greet.py and then press return, and that's going to run this program where I can type in my name and it's going to say hello to me. All right, so at this point, we now have these variables that are able to store information, and we're able to use that information later on in our program. And these variables open up so many doors for us in terms of what it is that we can do with our programs. And let's try and use these variables to do something interesting. Maybe one of the simplest computing machines I can think of is something like a calculator, something that can add and subtract and multiply and divide. So let's try to build a simple calculator in Python. I want to write a program that is going to add two numbers together. We're going to ask the user for two numbers, and we're going to add them together. So let's try it. I'm going to create a new file in my CS50 IDE, file, new file. I'm going to save the file, file save, and let's call this file arithmetic.py. And inside of arithmetic.py, I want to ask the user to type in two numbers. How do I ask the user to type something in? Well, if you remember from greet.py, I can use this input function to do so. So let me ask for input, asking for a number x. We'll just call it x, convention from algebra. And we'll ask for a second input on a second line, and we'll call it y. So now we have a program that is asking the user to type in two numbers. And we'll store those two values in variables. We'll store one inside a variable called x, and another one in a variable called y. So x equals whatever the first input is, y equals whatever the second input is. And now down below, let me just try printing out x plus y. I want to ask for input, two values. I want to add those values together and print out whatever the sum is. Let's give this program a try. I can run Python arithmetic.py. I'm asked to type in a number x, so I'll type in the number 1. And I have the number y, I'll type in the number 2. And so now what's going to happen when I press return here? If I've typed in the number 2, I want to add 1 plus 2. What am I going to see when I run this program? Feel free to paste in the chat what you think I'm going to see when I run this program. All right, so I hope the answer would be 3, right? 1 plus 2 is 3, and so that's what I would like for the answer to be. But many people are correctly guessing that that's not what I'm going to see. For some reason, I'm seeing the number 12. Now, 1 plus 2 is not 12, so what's going on here? Anyone have a guess as to what might be happening here? And if you have a guess, feel free to pose it in the chat. What is exactly has gone wrong? Yeah, so as a number of people are saying, very good. These variables are strings. And remember that a string is just some text. And why are they strings? Well, this input function by default is just asking the user for some input. We're asking the user to type in some text. And that text could be a number, like the number 1, but it could also be a name, like the name Brian, or a word, like hello, for example. And so Python doesn't know what it is the user is going to type in. And so Python is just going to treat those inputs as strings, as text. And so down here on line 4, when I'm adding together 2 pieces of text, all Python knows how to do when we're connecting 2 pieces of text is to concatenate them, to take 1 and 2 and just put them next to each other, and we get 1, 2, which looks like the number 12, even though that wasn't quite what we wanted. So we need a fix. We need a solution to this problem. This might be the first example of a computer bug that we've run into inside of our program, but that's okay. Inevitably, as you start writing code, you'll have bugs in your program, and that just means we need to now look back to the program, figure out what went wrong, and figure it out how it is that we're going to fix it. So we need some way now of fixing this problem. And I see a few suggestions. I like Adla's suggestion that a couple other people have suggested too, which is to take these inputs and somehow convert them into integers, which in Python we call ints, I-N-T. And it turns out there's a function called int in Python that we can use to convert something into an integer. And this may look a little strange if you've never programmed before, but here's what's going on. We're asking the user to type in some text via this input x, which we've seen before. And that itself, whatever the user types in, is input to, in other words, it goes in between the parentheses of this function called int. And that function takes whatever it is the user types in and converts it into an integer. And so that integer we store inside of this variable x. And let's do the same thing for y. Convert it into an integer, store that inside of this variable called y. And now we're going to print out the sum. And so now if I run Python arithmetic.py, I type in x1, and I'll type in y2. I press return, and I see the number 3, which is what I would expect. My program now appears to work because we're now able to take 2 integers and add them together. I see Juan asking, how do you clean up your terminal as I have it? The easiest way to do that in the terminal is just to type the word clear. If you type the word clear and then press return, that will have the effect of clearing out whatever was in the terminal, and then you're welcome to proceed from there. Anna is asking, how do you make a comment in Python? So a comment in programming is just some text written in a human language like English that's just useful for the programmer or for someone reading the code to understand what it is the code is about. The computer doesn't care about the comments. The computer is just going to ignore them. It's just for readability's sake. And the way to create a comment in Python is to use the hash mark. So above line 5, for example, I could add a hash mark and just say add 2 numbers together. You usually will use a comment to describe what it is some piece of code is doing, and it's just going to be a helpful reference when you come back to this code later so that you can understand it as well. And so if you want to be taking notes on the programs that I write by adding comments, certainly welcome to do that. You can add as many comments as you like that start with this hash mark. The computer will ignore them when you're running the Python program, but you will be able to see them in the text file just to see what it is going on in the program. All right. And so we don't just have to add two numbers together in Python. Python supports other operators too. So for example, I could subtract two numbers. I could say, let's run python arithmetic.py and do like 10 minus 2. And we see the answer when we subtract those two numbers. To multiply two numbers, instead of using a plus or a minus, I use the asterisk, which is above the 8 key on most keyboards, that multiplies two numbers together. And so now I have a program that I can give it two numbers as input, and it will multiply those two numbers together. And for division, you can use a slash. Slash is division in Python. And so I can divide two numbers. I can say, what is 10 divided by 2? And I see that the answer is 5, for example. Renee says, I accidentally closed my terminal. How do I get it back? So if you accidentally close your terminal by clicking on this X here, you can always get it back in CS50 IDE by clicking on this green plus button. And when you click on the green plus button, you'll see a new terminal option that will open up a new terminal. So you'll be able to see it. Oh, Beth has a great question too. Beth is asking, why did I get a decimal point just now? I got 5.0. And in all of the other cases, I just got like a number, like 8 or 28 or 3. Why is it that I'm getting this 0.0 at the end? Anyone have a guess? Why am I getting a 0.0 at the end of this number for division? Yeah, I see a lot of people using this word float. And if you've never heard the word float before in programming, it's short for the idea of a floating point number. And a floating point number is just any number that potentially has a value after the decimal place. It can be a fractional value. Unlike an integer, which is just going to be like 1, 2, 3, 4, 5, 6, or a negative number, or 0, for example. An integer could never be the number 2.5, for example, because it has something after the decimal. Floating point numbers can have things that are after the decimal. And Python is just assuming that when I divide numbers together, that we're going to give you a floating point number, because it's possible that when I divide two integers, it's not going to divide evenly into each other. So for example, if I had done 3 divided by 2, I would get 1.5, a floating point number, because 3 divided by 2 is not going to be a perfect integer. And so that's why we get that when we're performing division. All right, so let's go ahead and try something else now. So far, we've been writing code on multiple lines, and then Python is just going through all that code one line at a time, running every line of code. Where programming really starts to get powerful, though, is when we have the ability within our programs to make decisions. For our program to decide, yes, now I want to run this part of the code, and no, now I don't want to run that part of the code. For the computer to be able to make those judgment calls and make some decision about what code to run. And in programming, we call that a condition, where we're asking a question, like, should I run this code or not? And if we should, then we're going to run some piece of code, but otherwise, we're not going to. And so let's take a look at an example of that. I'm going to open a new file. I'm going to call it conditions.py. And inside of conditions.py, let me first ask for input from the user. I would like the user to type in a number, x, for example. And now I want to do something with that variable. I'm going to say, if x is greater than 0, let's print positive. So this first line we've already seen. It's a line that asks the user to type in a number. We're storing that number inside of this variable called x. Line 3 is our first example of a condition. We're asking a question. If x is greater than 0, we're asking, is x greater than 0? At the end of the condition comes a colon, meaning if the answer to that question is true, if it is true, then do whatever code follows. And the code that follows must be indented in Python. That's a requirement. And it's indented so that Python knows only to run the indented code if this condition is actually true. So if x is actually greater than 0, then we're going to print positive. So let's give it a try. I'm going to run python conditions.py. I'm asked to type in a number. I'll type in a positive number, something like 2, for example. And we do see that positive gets printed out. But watch what happens if I type a negative number. I type -8, for example. And now notice that nothing gets printed out. We just see the prompt immediately again. And so the reason this is happening is because we're asking this question. We're asking, is x greater than 0? And if it is, then we're running this code inside of the condition. And if it's not, then we're not bothering to run that code that's inside of the condition at all. So these conditions give us this ability now to make these kinds of decisions. And now Kate is asking a good question. Can you do an if-else? Yeah, great question. An else in programming is just a case that handles what happens if the condition is not true. Right now, we're printing positive if the number is greater than 0. But if this wasn't true, we're not doing anything at all. So here I can say else followed by a colon. And then also indented, I'm going to print negative. And so here I've effectively created a fork in the road, two different branches where the program's only ever going to take one or the other. If x is greater than 0, then we go down this road and print out the word positive. And else, otherwise, we have a colon to introduce a new block of code. And then indented, we're printing the word negative. So now if I run this for a positive number, it prints positive. For a negative number, it prints negative, for example. All right, a couple of people have caught on to a little bit of a bug in my program. Yeah, Hassan just mentioned it. Richard's mentioned it too. Seba too. What about 0? What happens if I type in 0? And so someone guess for me. If I type in 0, what is the program going to say right now in this program? Yeah, it's going to say negative, as several people have caught on to. I type in 2, it says positive. I type in a negative number, it says negative. But if I type in 0, it also says negative. And the reason why is because we check, is 0 greater than 0? Well, no, it's not, so we don't run this piece of code. So we go to the else, and we end up running that piece of code. And so that is not exactly what I want. I'd like to modify this a little bit. And I like Akash's suggestion that a couple of other people have suggested too, which is to use a keyword called elif. Elif is short for else if. It means if the previous condition wasn't true, let's check another condition. So else if x is less than 0, let's go ahead and print negative. And else, let's print 0. So we can chain these conditions together. I can say if x is greater than 0, let's print positive. Otherwise, if x is less than 0, let's print negative. And otherwise, if neither of those were true, then we're just going to print 0. Only one of these will ever happen for any run of this program. But now, when I type in the number 0, we see that I do actually get a 0 at the end. Sebastian's asking, does the order of these matter? The else needs to be the last one. The else needs to be the one at the very end because you check all of your conditions and then if none of them were true, the else comes finally. But the order of the conditions is the order in which they're checked. So this means we're first going to check for positive numbers, and then we're going to check for negative numbers, and then we do the else if neither was true. You could rearrange them so that we check for negative numbers first and then positive, and that would certainly work. And depending on what you're trying to create, what you're trying to write, you might have different orderings of conditions that would make sense for that particular program. To answer a question about brackets, if you've used a language like C or Java before, your conditions might have had curly braces around them. We don't have those in Python. We just have a colon at the end of the if statement saying, here comes a new block of code. And you do need that colon there. It's a requirement. And then you need some indented code to make clear what code is actually part of that condition. All right. So conditions offer us a lot of power when it comes to trying to create more interesting programs because it gives us the ability to branch in different directions to make decisions. Another quite powerful tool within the programmer's toolbox is the loop. And loops are all about the ability to take some code and run it multiple times, which happens quite often in programming, that you have some code you want to run multiple times. Let's imagine, for example, that I want to print hello world multiple times. I'll create a new file. I'll call it loops.py. And if I wanted to say hello world, let's say 10 times, how would I do that? Well, inside of hello.py, I'm already saying hello world one time. So the easiest thing to do would just be to paste this 10 times. I'll copy paste it. And here's now 10 hello worlds. I can run the program now by running python loops.py. And I see hello world printed 10 times. Exactly what I wanted, but I would argue that my code is not well designed. This is not particularly good code. And why not? Why is this not particularly good code? Muhammad says my code's not concise. Yeah, I'm using a lot of lines of code, 10 lines of code. I might be able to do it more efficiently, more succinctly. So this is probably not the best design. Anina is saying I have redundant lines. I've copied myself. I've repeated myself by using the same code multiple times. And this is a common principle in computer science and computer programming, which is that you want to, as much as possible, try not to repeat yourself. If you find yourself copy pasting the same code a lot, there's probably a better way to do that. And Justina is saying it's not flexible. That if I wanted to, for example, change the number of times I'm printing hello world, I don't want to print it 10 times, but I want to print it 50 times or 100 times. Well, then I'm going to have to make a lot of modifications to this code, and I'm going to have to repeat myself many, many times. So for all of those reasons, those are all great reasons, this is not the best design for this program. And what I want to use is I want to use a loop. And so there are a couple of ways that I could do this. I'll demonstrate a couple of them, but here's one way. Let me create a variable called I. I is going to be 0. I is just a common name for a loop, for a variable that's going to keep track of a loop for me. And what I is going to keep track of for me is it is going to keep track of how many times have I run a certain piece of code. How many times have I printed the words hello world. And now watch what I'm going to do. While I is less than 10, let's print hello world and then say I equals I plus 1. So what's going on here? While I is less than 10 is introducing what's called a while loop. A loop is just going to be a part of my program that is going to repeat code over and over as long as this is true. As long as I is less than 10, we are going to keep running this code. There's a colon after the while loop to say we're introducing the code that we're going to loop, and all of the looping code must be indented, much as it was with conditions. We've indented all of the code that is inside of that loop. And so we're saying as long as I is less than 10, let's go ahead and print hello world. And then I equals I plus 1, which might seem a little strange because I is not equal to I plus 1. Those are two different values. But remember that the equal sign in Python performs assignment. It assigns a value to a variable. And so what we're doing here is calculating what is I plus 1. And whatever it is, we're making that the new value of I. In other words, we're adding 1 to I. Because if I were 0, then 0 plus 1 is 1, so I would become 1. If I were 1, then 1 plus 1 is 2, and I would become 2, so on and so forth. So I starts at 0, we print hello world, we add 1 to I. Now I is 1, we check. 1 is still less than 10, so we print hello world. We increase I again, now I is 2. Then 2 is still less than 10, so we print, and we do that again and again and again until I is 10. And at that point, 10 is not less than 10, so the loop is going to be over. So I can try that now, python loops.py. And we see hello world printed 10 times. And we've done so more succinctly using just 5 lines of code. And one of them is a blank line, so really it's just 4 lines. And we could easily modify this. Just by changing this number 10, we could change how many times the loop was going to repeat. A few people have pointed out that line 5 here I could simplify a little bit. Ved, for example, one of our mentors, is suggesting that instead of I equals I plus 1, it turns out it's so common in programming for programmers to want to add a value to a particular variable that there's a shorthand for it, a faster way of doing it, which is I plus equals 1. It means exactly the same thing. So if I equals I plus 1 makes more sense to you, keep doing that. But to be a little bit more concise, I can say I plus equals 1 to say, go ahead and add 1 to I, just a shorthand for adding some value to a variable. And so this will do the same thing, print hello world 10 times. But as a few people have suggested now, if you know exactly how many times you want a loop to run, like I want this loop to run exactly 10 times, it turns out there's another type of loop that we have in Python that we can take advantage of. A while loop is going to loop code as long as some condition is true. And we'll see some use cases for that later. But here, when I'm looping something exactly 10 times, there's a little more of a concise way of accomplishing this using a different type of loop. And this type of loop is called, as Akash pointed out, a for loop. And here's what a for loop would look like. I'm going to say, for I in range 10, print hello world. And that's it, actually. Range 10 is a function in Python that's going to give me 10 values. It turns out it's 10 values from 0 up through 9, just 0 through 9, the first 10 numbers starting at 0. And for each value in that sequence, so for 10 times, we are going to run this code. We're going to print hello world. And this does exactly the same thing. I run python loops.py, and it prints hello world 10 times. But I could change this. If I only wanted the loop to run 5 times, I would say for I in range 5, and now the program is only printing hello world 5 times, for example. And so if I know, yeah, I just want this loop to run 5 times, this type of syntax can be quite concise. And we could even take input from the user to make this decision as well. I can, up on the first line, let me ask the user for input. N is going to be an integer input from the user. I'm going to ask them to type in a number. And this is a line of code that we've seen before, lines of code that are kind of like this. And then, instead of looping 5 times, here range 5, instead I'm going to say, let's loop n times. So line 1 we've seen before, we're asking the user to type in a number. And now whatever number they type in, that's how many times we're going to repeat this loop, printing out the words hello world. So let's try it. Python loops.py, let me type in the number 3, for example. And when I type in 3, I see hello world printed 3 times. If I instead run this program and I say 8, for instance, now hello world is going to be printed out 8 times. Each time we're asking the user for input, storing that input inside of a variable that we're here calling n, and then we're looping n times, printing out the words hello world. I'll pause here for questions about anything we've written so far. All right, so with that, let's go ahead and try an exercise of your own. I'm going to stop talking in a minute, but I'm going to give you a problem in Python to try to work through by yourself. You can look back to the code that I've written as some reference, but you're going to have an opportunity to put variables and loops and print statements into practice. And so for a little bit of context, I've been doing a little more exercising lately. I've been doing some running. And let's say, for example, that I've run on 10 different days and I've run a different distance every day. And what I'd like to do is add up how much I've run on each of those 10 different days so I can see in total how far have I run. And so you're going to help me with this. Here's how you're going to do this. What I'd like you to do is write a program in CS50 IDE in Python called sum. You can create a new file called sum.py. And what you're going to do is write a program that asks the user to type in 10 integers, and then you're going to print out their sum. So you're going to give the user 10 opportunities to type in 10 numbers. And at the end of typing in those 10 numbers, you're going to print out what the total is, the sum of all of those 10 values. And I'm actually going to stop talking in a moment, and I'll give you something like 10 minutes to try working on this problem on your own, writing it in Python. If you have questions at any point, if you struggle or you run into a problem, go ahead and ask a question on ED, the course's discussion forum. You can find it here at this link that I just pasted. I'll show you how it works now. You can go here, click the new thread button to create a new thread, click on question to ask a question, and then in the category, click on Python, which is today's seminar, and you can ask your question here. You can include the code that you've written here too, so that the mentors can look at your code. And we have a fabulous team of mentors who are here today, who are here to look at your questions and to answer them and to help you out as you go about writing this Python code. So this is what we're going to work on for the next 10 minutes, write a program that asks the user to type in 10 integers as input and then prints out their sum. Feel free to stay in this meeting because in 10 minutes, we'll review the solution, we'll go over it together and take a look at some other features of Python as well. And so what I'm going to do right now is start a 10-minute timer. You should be able to see the timer if you look at my video tile here, but I'm going to stop talking and give you 10 minutes to work on this. and then we'll talk about it. So we will see you in 10 minutes. All right, welcome back, everyone. Hopefully you were able to make some progress on that. What I'd like to do is open it up to see if anyone would like to offer their thoughts on how they approached the problem. So if you'd like to offer, maybe not an exact code, but what kinds of programming ideas did you use, and how did you go about thinking about the problem? If you'd like to raise your hand virtually within Zoom by clicking on the raise hand button, we can see if we can take a volunteer for how you might have approached this problem. Let's go to Arthov, if you'd like to go.
Hello. So first I took as an input 10 integers inside some kind of a loop and just added all those integers, and after that I printed it so that I could get the sum of it.
All right, so some kind of loop. I like that idea. Some loop that's going to be adding together a whole bunch of numbers, and then at the end of all of those numbers, we can print out what their total is, and somehow inside of that loop, we need to be keeping track of what our total is so far. I see a lot of people using a similar idea here in the chat. I see some for loops, I see some while loops. So I'll show you one way that you could have solved the problem, and there were many ways to solve this problem and all of the problems that you're going to be working on. And so there's not necessarily one exact right way to do it. With programming, there are often multiple possible approaches that could work. But here's one way. I need some variable for me that's going to be keeping track of what the total is so far, that I want to add up all these numbers, and I want to calculate what their total is going to be. So let me give myself a variable called total, which will start s equal to 0. And now let's have a for loop. And remember, for a for loop that runs 10 times, I could say for I in range 10. And what do I want to do inside of this loop? Well, I want to ask the user to type in a number. So let's ask the user to type in an integer. We'll save it inside of this other variable called n. And now I'll say total equals a total plus n. I would like to add n to whatever the total is. I could, of course, use the shorthand total plus equals n, which we've seen already now, which just adds the number n to whatever the total is. And then at the very end, let me print out the sum is, and then I'll just print out whatever the total variable is. So let's give it a try. We'll do python sum.py. I'll type in 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And at the end, my program says the sum is 55. So that was how we could use a loop to achieve something multiple times. Multiple times, we want to prompt the user for a number and add that number to the total. And so we could do something like this in order to calculate the sum of those values. But Tool is asking, why did we do total equals total plus n? What we want to do is we want to be keeping a running total of what the sum is so far of all the numbers that we've added. And so the idea is that as we keep getting more and more numbers provided to us by the user, we want to keep adding those numbers to some kind of a running total. And that's what this variable is going to do. It's just going to keep track. For every new number the user types in, let's add that to the total and add the next one to the total until we have the total for all of them. So for loops are quite good for something like this when you want to run your code a certain number of times. And sometimes, though, you don't know how many times you're going to need to run your code. So for example, imagine a program where you want the user to type in a positive integer. And that might happen, for instance, in a banking application, where if the user is trying to type in some amount of money that they want to deposit, you don't want to let them deposit a negative amount of money, for example, because that probably wouldn't make a lot of sense. And so you might require that whatever the user types in is actually a positive integer. And for that, what we'd like is a program where if you don't type in a positive integer, the program asks you again and asks you again until you type in a positive integer. But we don't know how many times we might need to ask them. The user might get it right the first time, or it might take 5 to 10 times for the user to finally type in a positive number. So we don't know exactly how many times this loop should run. And this is where there are constructions that use a while loop that can be quite good. I'll show you one example that comes up quite frequently. I'll create a new file, called positive.py. And here's what I'll do. I'll say while true, and while true is going to keep running code as long as this condition is true. And it turns out that in Python, if I use capital T true, that is a value that is always going to be true in Python. It is true in Python. And so this loop is going to run forever. It's just going to keep running again and again. It's what we might call an infinite loop. And ordinarily, you might think an infinite loop's no good because there's no way to get out of it. It turns out in a moment, we'll see there is a way that you can exit. In other words, break out of a loop. But we'll explore that in a moment. So here, we'll say n is going to be equal to an integer input. We're going to ask the user for a positive integer. And then, when do we want to exit this loop? We want to exit the loop if n is positive. If n is greater than 0, then n is a positive integer, and we don't need to loop again. We can just exit the loop now. So here I could say something like, if n is greater than 0, then let's go ahead and break. Break is a special keyword, meaning exit the loop. Whatever loop you're in, break out of that loop, and then we'll move on to the rest of the code. And what will the rest of the code do? Let's just print out the number n. So now if I run python positive.py, I can't type a negative number. It prompts me again. If I type a negative number, it prompts me again. I type in 0, it prompts me again. Only when I type a positive number do we break out of or exit that loop. And at the end, we end up seeing the value that we typed in. In answer to a question, yes, case does matter with these Python keywords. While and int and input, these are all lowercase. True is capital T true, and likewise false is capital F false in Python. And that's just part of Python's nomenclature. And so you do need to include that capitalization there. So these now are a couple of uses for loops. Let's now try to create a new program that's going to take advantage of these loops, that's going to involve a little bit of logic. It is shortly after the new year, just a couple weeks into the new year. And so convention on Happy New Year is to count down to the new year. You might count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, Happy New Year. Let's try to write a program in Python that counts down to the new year for us. So I'm going to create a new file. I'm going to save that file by going to File, Save. Let's call the file countdown.py. And now how could we write a program that counts down to the new year? Well, we could write print 10, then print 9, then print 8, then print 7, then print 6, 5, 4, 3, 2, 1. Happy New Year. So 11 lines of code, print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, then print Happy New Year, and this works. I run python countdown.py, and now you see the countdown, and at the end of the countdown, 3, 2, 1, we do see Happy New Year. So a couple of people are suggesting that this might not be the best option. Yeah, Akash is mentioning that I'm repeating myself again. I got a lot of print lines. Now, technically, I'm not repeating exactly the same line of code. All 11 of these lines of code are different, but it's the same logic. This logic of like, go change the number by 1, change the number by 1, change the number by 1. After you're done with all of the numbers, then print Happy New Year. And so let's puzzle through this. What logic could we use if we wanted to somehow loop 10 times and print out a number each time? What might that look like? Yeah, I see a lot of people suggesting a for loop. We've already seen that we can use something like for I in range 10 to repeat something 10 times. And let's go ahead and just print out I, because I is going to be each one of those 10 numbers. Effectively, I, each time the loop runs, is going to take on a different number in that sequence of 10 numbers. And so now we're going to count 10 numbers, and then we're going to print Happy New Year. What's going to happen when we run this program? Any ideas? Look at the program, think about what we know. What will we see if I try to run this program now? Yeah, it's going to count up, as several people are saying now. And it turns out it starts counting from 0. Range by default will start at the number 0. And so now if I run it, I see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Happy New Year. So probably not exactly what I wanted for my Happy New Year celebration. Is there an improvement I can make, though? Is there a modification I can somehow make that would allow myself to not count 0, 1, 2, 3, 4, but to count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1? Yeah, so I see a number of different suggestions, different possible ways to do it. Again, as usual, there are multiple ways you could solve any of these problems. But I see Baya's suggestion that a couple of other people have suggested now too, is to replace this I with a 10 minus I, which maybe looks a little bit weird at first, but let's think about what that's going to do. Initially, I is 0. What's 10 minus 0? Well, that's 10. Then I is 1. What's 10 minus 1? Well, that's going to be 9. Then I is 2. 10 minus 2 is 8. So we're going 10, 9, 8, 7. And we are now counting down from 10. And we're going to count 10 numbers. So if I run this program, Python countdown, we see 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Happy New Year. So finally, after figuring out, puzzling it through, coming up with a loop, coming up with what math we might want to do inside of that loop, we now have a program that can print Happy New Year. Now, this is some interesting logic, and it's nice that we've come up with it. Imagine now that I'd like to write a program that can wish people Happy New Year in different time zones. That maybe I wanted to wish me a Happy New Year here on the East Coast, but I have other people I know who live on the West Coast, and I'd like to say Happy New Year to them. West Coast of the United States is a couple hours behind, so I want to print Happy New Year a little bit later. Well, I could just copy this code and paste it again, and now I've got more code that's going to print Happy New Year. And now I run this program, and it counts down to the Happy New Year, and it counts down to the Happy New Year again. But here again, there's room for improvement, room to make sure that I'm not repeating myself. Anytime I have useful logic, like here I've got this interesting logic that counts down for me, which was not simple to do. We had to think about it a little bit. We had to come up with the right loop. We had to come up with the right math to do. It can be helpful to create our own function. Now, a function, remember, is just some piece of code that accomplishes some task. And we've been using functions all day today in this seminar. We use the print function, we use the input function, and a number of other functions as well. But it turns out we can write our own functions. So let me try to do that now. I'm going to define a new function by saying def countdown. This keyword def is a keyword that just means define a new function. And inside that definition of a function, I'm going to name the function. What's the function called? I'll call it countdown, but I could call that function whatever I would like. Then come a pair of parentheses. Remember, functions that are allowed to accept input. And if my function did accept input, I would include the input there. Right now, I'm just counting down from 10. There's no input to the function. So just empty parentheses. Next comes a colon. And after that, indented are going to be all of the lines of code inside of this function. And what I want inside the function are really these two lines that are going to perform the countdown for me. So this now is a function that I have defined called countdown that is going to count down from 10. Now I'm going to use that countdown function. And once I start writing programs with functions, it's often helpful to have one main function that is the primary function that runs when I run my program. And so to do that, I'm actually going to define a second function called main by saying def main, define a new function called main. And what is the main function going to do? Well, it's going to count down, and then we're going to print Happy New Year. So the main function counts down, and then it prints Happy New Year. Let me now run this program, Python countdown.py. And nothing happened. I just see the prompt again saying, okay, you can type another command. Nothing was printed. I didn't get a countdown. I didn't get a Happy New Year. What's wrong? What did I do wrong here? Yeah, one of our mentors, Alexandrina, saying, I haven't called the main function. To call a function just means to use that function. And here I'm defining functions. I'm saying this is the main function and this is the countdown function. But defining the function isn't the same thing as running the function, as using the function, as calling it. And so down below, I need to say main and then a set of parentheses to say call the function main. Actually run that code, which will run the countdown and then print Happy New Year. And now, only now that I'm calling the main function, do I see the result I want, which is a countdown from 10 and then Happy New Year. All right, so let's make some improvements to the program. One possible improvement is that maybe we don't always want to count down from 10. Maybe sometimes we'd like to be able to count down from 5 or count down from 15, for example. How could we do that? And so if we wanted to do that, what I'd like is for my countdown function to be a little bit more flexible. Right now, the countdown function is always counting down from 10 every time, and it can never count down from a different number. And so how would I allow the countdown function to accept some input, to not just count down from 10, but count down from any number that I want? Well, I can do that by giving countdown an input. I'm going to give it an input. I can name it whatever I want. I'll go ahead and call it n. But now what I'm going to do is instead of counting down from 10, I'm going to count down from n. So for I in range n, and print n minus 1. And so now I can count down from whatever number I want. If I wanted to, I could count down from 10. And the way I would do that is that inside of the parentheses for the countdown function here on line 2, inside of my main function, I would pass as input to the countdown function. And remember, the input always goes in between those parentheses. I could use the number 10. And that would give me a countdown that starts at the number 10 and counts down to the new year. Of course, I could also use 5 or some other number. And now, without changing the countdown function, I'm counting down from 5 just by changing the input to the countdown function, otherwise known as the argument to the function, as a few people are saying in the chat. So this now gives us the ability to count down. Now, a few people are calling me out on the fact that I'm not really doing a countdown here because all of the numbers are appearing all at once. It's not like one number is appearing every second. And so to do that, what I'd like is a function that like waits 1 second. And I could try to write a function that waits 1 second, but honestly, I don't know where I would start with that. It sounds like it would be difficult to do, but I don't have to worry about that. Python gives you access to a number of what are called modules, existing pieces of code that have already been written by programmers that we can just use inside of our program. And it turns out one of those modules is called the time module that is just used for time-related things like delaying. So on line 1, I'm going to include this line import time that is just going to import this time module and give me access to all of those functions inside of the time module. And one of those functions is called sleep. So inside the countdown function, after I print out a number, I'm also going to say time.sleep1 to mean go ahead and sleep for 1 second. Pause for 1 second, and then keep going. Let's try it again. Python countdown. And now we see 5, 4, 3, 2, 1, Happy New Year. 1 appearing each second. And at the very end, we do see the message, Happy New Year. And there are all sorts of other modules you could import to do interesting things. One fun one is that right now our program is doing the same thing every time we run it. It is always going to be the same every time. We can make our program a little more interesting by introducing some randomness into the program to generate, maybe don't count down from 5, but count down from some random integer. How could we do that? Well, just as we could import time, we can also import random, a module that gives us access to other randomness-related functions. Now I'll generate a number. We'll say number equals random.randint. And random.randint is a function that accepts 2 inputs, a lower bound and an upper bound, on what range of numbers do I care about generating. And so let's get a number between 5 and 15, let's say. And now instead of counting down from 5, let's count down from number. Now I run Python countdown.py. And this time it's counting down from 15. It just chose the number 15 as the number to count down from. But it won't necessarily always do that. After this finishes its count, I'll try it again. So it says count from 15, then Happy New Year. I try it again. Now it's counting down from 13. So each time it's picking a different random number between 5 and 15. Maybe I'll get the same one twice, but in general, it's choosing it pseudo-randomly. And we get that number, and it's going to count down from that number. Davika is asking, how can I see all of the available functions in a module? How did I know there was a random.randin? How did I know there was a time.sleep? You get it through what's known as the documentation for the module. The documentation you can think of as the instruction manual for the module that tells you what types of functions you can use. All of the built-in Python modules have documentation. You can find it on Python's own website, and you can use that reference to understand how these functions work. And with practice, you get used to using them inside of your own programs. So now that we have this, the ability to have these conditions, the ability to have loops, variables, and now randomness introduced into the mix as well as we start to build some more complex programs, I'm going to give you a new program to work on, something to work on for a few minutes, and then we'll talk about it as we did before. And here's the program you're going to create. It's going to take advantage of this randomness. So pay attention to how I used random.randint here to generate a pseudo-random number. You're going to write a guessing game program. So create a program called guess.py, for example, inside of which you're going to write a program that picks a pseudo-random number between 1 and 10 and gives the user up to 3 chances to guess that number, each time printing some message letting the user know if they were correct or not. And so what might happen is the computer will pick a number. Maybe the computer picks number 4. And then you would make a guess. You would let the user guess, oh, 5. And your program might say, oh, your number's too big. And then you might say, all right, let's guess 3. And the program might say, oh, your number's too small. And if your user then guesses the number 4 correctly, then you would say, all right, you succeeded. You got the number correct. And so that's what we're going to try to do. I'll give you about 15 minutes to work on this, to write a program in Python that picks a number at random and gives the user 3 tries to guess that number. You're going to put some of these ideas to use. As usual, if you have questions, go ahead and post them to the Ed discussion forum, the link to which I just put into the chat here. You can post your code there and ask for help if you're struggling with how to solve a particular portion of it. But I will go ahead and stop talking and give you about 15 minutes to work on writing this. And the mentors will be around in the next 15 minutes to help you out. At the end of those 15 minutes, we'll talk about it. So we'll see you in 15 minutes. All right, welcome back, everyone. Would anyone like to offer their thoughts on how they approached this problem? What you were thinking, what kinds of ideas from programming you were using as you were writing it? Thoughts about how it is that you solved the problem. Let's go to Richard. Richard, I don't think we can hear you.
Sorry, can you hear me now?
We can hear you now.
Excellent, good stuff. Yeah, I used loops and variables basically. So using the import time and the import random, I then created a variable which I had as a random randint between 1 and 10. I then prompted the user to give me a number to guess between 1 and 10. I then used a for loop with a range of up to 3. And then had another variable which was n, where I asked the user for input, so they gave me some input, and then used an if statement within that for loop that said if n equals, or so not just equals but equals the number value should be a random number, then it would then say, it would print out saying yes, you won, and then break. Whereas if it didn't meet that, then it would just loop again. It would just resolve the loop and just say, and it would prompt the user, try again, basically.
Yeah, sounds great. So using random.randint to generate a random number, storing that inside of a variable, some kind of loop that's looping 3 times to let the user have a couple of guesses, and then storing their guess inside of a variable as well. I think those are going to be some of the common elements that I've seen a lot across some of the code that I've seen from you today. And let me demonstrate now what it might have looked like. Again, yours might not look exactly like what I'm about to write, but there are multiple ways that you could go about trying to solve this problem. So as Richard mentioned, we probably need to start off by actually getting a random number. So I'll import random at the beginning. And let's have number is going to be random.randint 1 and 10. So we're going to get a random number between 1 and 10. And now we want to give the user 3 tries to guess that number. So I could say for I in range 3 to repeat some code 3 times. And now what could I do here? I could say, let's have the user type in their guess. I'll say guess equals int input guess. And this construction of input inside of an int, we've seen a couple of times now, just gets information from the user, turns it into an integer, which is what we want in this case. And now I can have some conditions. If the guess is greater than the number, let's go ahead and print guess is too large. And elif, meaning otherwise, if the guess is less than the number, we can print guess is too small. And then else, we can print correct. Because if you weren't too big and you weren't too small, the number must be the correct number, for example. And one final thing you could have added is to break out of the loop if you get it correct. Remember that break is a keyword that we can use to exit a loop, because if you get it right on the first try, you don't really need 2 additional tries. We may as well just break out of the loop now. So those lines then will generate our random number and give the user 3 opportunities to guess it. I can try it out by going to python guess.py. I type in a guess. I'll try 5. Guess is too large. All right, I'll try smaller. I'll try 3. Guess is too large, so it's got to be 1 or 2. Let's guess 2. Guess was still too large, so I didn't manage to guess it that time. Maybe you'll have better luck if you try it as well. I see a great question from Chloe. Why can't we use the equal sign in the if statement? You maybe tried to do something like if guess equals number, then print correct. And I would like to be able to say something like that if I check to see if the guess is equal to the number, then print correct. But it turns out this doesn't work. If I try to run this, I'm going to get a syntax error. Python's reporting an error to me. And whenever Python reports an error, it tells you where the error is happening. It's telling me the error is on line 7, and it's something to do with that equal sign. So that equal sign is causing the problem. And the reason why it's causing the problem is because the purpose of the equal sign is to assign a value to a variable. We use it on lines like line 3, where we say pick a random number and use the variable number as the storage for that new value. And so the equal sign in Python means assign something to a variable. It does not mean check to see if two things are equal. The solution, as several people have said in the chat, is to use two equal signs instead of one. Two only just because one was already taken for something else. Two equal signs in Python means, are these two numbers equal to each other, true or false? And so we can put that in a condition. If the guess is equal to the number, we print correct. So that's one thing we could do. Of course, the other way you could have done it, which is the way I did it here, was just not to have a check for equals at all. Just check if it's greater and check if it's less. And if it's neither of those, we'll then just go ahead and print correct. All right, I'll give people a chance to follow along with that. 10 does get included when you use random.randint. It is one possible value that it can take on. In answer to a question in the chat. And the number will be different every time in answer to another question. So just now the answer was 1. Maybe I'll by chance get 1 again, but odds are it'll be a different number this time. I can try 5. Now my guess is too small, so I got to try another number. I'll try like, let's try 8. Try 8. Oh, 8 is correct. And so we got the number right in 2 guesses. So this time it was 8. All right, so a couple final things I want to show you with regards to programming in Python. One is the ability of functions not only to have inputs, but also to have outputs. That we've seen functions that have output already. For example, random.randint produces an output, which is a random number. The input function also produces an output, which is whatever it is the user typed in. And functions produce outputs anytime we want to take whatever a function is producing and use it later in the program. So what's a use case for this? Let's imagine we are writing a game in Python, and we need to figure out who won the game by comparing 2 players' scores and figuring out which score is bigger. To do that, ideally, I would like a function that can take 2 numbers and tell me which of those 2 numbers is the bigger number. Let's try to do that. I'll create a new file. I'll call it maximum.py. That's what I'm doing here. And let's define a function called maximum that can compare 2 numbers, A and B. What does that function look like? Well, how do I know which one's bigger? I can just check. If A is greater than B, then the bigger one is A, and so I'm going to return A. And now return is a new keyword that we haven't seen before, but all return means is exit the function and use whatever comes next as the output of that function. Return A means the maximum function is now over, and whatever A is, that's going to be the output of the function that I can then use somewhere else in my program. I can add an else. Otherwise, if A wasn't the bigger one, then let's go ahead and return B. And so I now have a maximum function that checks 2 numbers and figures out which one is the bigger one. And so now I can use that function in my main function. I can define a function called main. Let's ask for 2 numbers, x and y, as we've done before. Ask for an x, ask for a y. And now let me let z be the maximum of x and y. Take these 2 variables, x and y, pass them as input into my maximum function. And whichever one the bigger one is, that's going to be the output of the function. And therefore, that's going to go into this variable z. And now I'll print out the maximum is z. So here, I'm printing out which of those 2 values is the maximum. And let's give it a try. I will type main to run the main function, run Python maximum.py. I type in 2 numbers. I'll type in 2 and 8, and I see the maximum is in fact the number 8. So it's able to take 2 numbers for me and tell me of those 2, which one is bigger. Joanne, I created the main function just for keeping my code organized, that often once you have other functions, like I have this maximum function, it can be helpful to have a main function as well, just to make clear what code belongs where. You didn't, strictly speaking, need the main function. I could have just put all of this code outside of a function and it would have run as well. So this is where functions now can get quite powerful, the ability to have inputs and also produce outputs that we can then use elsewhere inside of our program. Let's see some other examples now of where that might prove handy. Let's imagine we're still working on this game where players are accumulating scores, and maybe I want to visually plot their scores, doing a little bit of very simplistic computer graphics, where I might want to print, say, a bar chart of a user's score. That if they, and we're going to, for a bar chart, we're just going to use the hash mark. So if the user scored 5 points, I want a horizontal row of 5 hash marks to represent 5 points. So let's try and do something like that. I'm going to create a new file. Let's call it scores.py. And here I'm going to have a main function where I'm asking for a score, which will be an integer input from the user. And now how do I print out hash marks, 1 for each point the user has? Well, let's run a for loop. For I in range score, we print the hash mark symbol. So that seems straightforward enough. We're asking the user to type in a score. And now we have a loop that's going to loop that many times, each time printing a hash mark. So I can try this, Python scores.py. Let me say my score is 4, for example. And okay, I did get 4 hash marks, but they weren't in a row. They ended up in a vertical column. Why is that? You know the answer. In fact, we've already seen a similar issue earlier today. Why is it that I'm getting 4 hash marks in a column instead of in a row? Yeah, every print statement by default is printing a new line at the end of it. Exactly right. I'm writing print followed by the hash mark, so it's printing the hash mark, then a new line, then it prints another hash mark and a new line, then a hash and a new line, so on and so forth. And that's not what I want. I would like for everything just to be on one line. So how can I do that? Well, it turns out you can override what comes at the end of the print by saying, after the string, comma for a second input. And then I can say end equals double quotation mark. The double quotation marks, 2 double quotation marks means this is the empty string. It is text with nothing inside of it, no text at all. And so that's going to mean print nothing at the end. Instead of the usual thing you print at the end, which is the new line, just print nothing at the end of printing that hash mark. And let's try that. Now I'll run Python scores.py. I'll type in a score of 4. And we see, okay, 4 hash marks and the prompt immediately, which maybe doesn't look all that great. I usually want the prompt to appear on a new line. So in saying print nothing at the end, I got rid of all of the new lines, including the new line at the very end after the loop was entirely done. And so to add a new line back, I am going to, on a new line outside of the loop, so not indented inside of the loop, I'm just going to say print. Print in this case is saying print nothing, but because print automatically adds a new line at the very end, we are going to just print a new line at the very end. Asan is asking why we're using the hash mark. We didn't have to use the hash mark. We could have used any other symbol. We're just using the hash mark as our visual indicator here because it's a symbol that takes up space. But now, when I run the program, I can say, let's do 4 points again. And now we see a horizontal row with 4 hash marks. So this is great. I now have the ability to get a score for one user and print out hash marks for that user. Let me do this for 3 different users now. If I want to print out 3 scores in a chart, let's get score 1. And I'll repeat this for score 2. And I'll repeat this for score 3. And now I'll have one loop that prints out score 1. And I'll repeat these lines for the other ones. I'll repeat it again for score 2. And I'll repeat it one more time for score 3. So now I'm asking the user for 3 numbers. I store them inside of these variables, score 1, score 2, and score 3. And then I have these loops that loop over each of those scores and prints out whatever that score is. Oded is looking ahead and saying the design is not good. Yes, that's true. But we can still run it. I can say, let's do 2 points and 8 points and 5 points. And we do see a bar chart with 2 points and 8 points and 5 points. But we're right. We can do better. And Alexandrina is suggesting we can define a separate function for printing these hash marks. So how could I do that? This is the logic that's in common, this logic that's printing out hash marks again and again and again. And so let's separate that into a different function. Let me define a new function that's going to be called print score. And the print score function is going to accept as input a number n. And n is going to represent how many times I should print a hash mark. How many hash marks should I print? So instead of printing like score 3 hash marks, I'm instead going to print n hash marks, printing a hash mark with nothing at the end, and then printing a new line at the very end of that. And now that I have this function, I can simplify some of the rest of my code. Instead of all of this, I can just say print score, score 1, print score, score 2, and print score, score 3. And so this is now the simplified version of my code where I've organized my work into a function for the logically tricky stuff. And so I'm getting 3 inputs from the user, and then I'm just using this print score function to print for each user. Try it again. We'll do 2 points and 8 and 5. And we do see 2 bars and then 8 bars and then 5 bars. Let's do one other example involving functions before I give you one final exercise to work on. I'll create a new file. I'll call this one multiplication.py. Now, you might have had experience in grade school learning your multiplication times table as you learn 2 times 3, 2 times 4, 2 times 5, for example, just starting to get practice with multiplication. Let's write a function that can print out some of these multiplication facts that we could study, for example. So I'm going to write a function, define a new function called multiply that accepts 2 inputs, x and y. And it's going to print out what we get when we multiply x and y by each other. And so how would I do that? Well, I want to start by multiplying these values together. And maybe I'll store the result inside of a variable. So I'll say product equals x times y. And now what I'd like to do is print out all of this information. Print out, here's what you get when you multiply x and y. And so to do this, I'm going to print out multiple things separated by comma. So you'll have to follow along a little bit closely. But I'm going to print out x, the variable x, then a comma. Then in quotation marks, an asterisk for multiplication, then a comma. Then y, the variable y, then a comma. Then in quotation marks, the equal sign, and then a comma. And then product. So that we print out whatever x is times whatever y is equals whatever the product is. And so let's now use this function. Inside of my main function, which I'm going to define up above, I can say let's multiply 2 and 3. And let's multiply 2 and 4. Just to try out this function. And I add a call to main at the very end too. And so now I'll run Python multiplication.py. And here's what I see. I see 2 times 3 is 6. And I see 2 times 4 is 8. So it's printing out those multiplication facts because I told it to. On one line, I told it print out 2 times 3. On the next line, I told it print out 2 times 4. Now, what if I wanted all of the 2's times tables? I wanted not just 2 times 3, 2 times 4, but I wanted 2 times 0, 2 times 1, 2 times 2, 3, 4, 5, 6, 7, 8, all the way up to like 2 times 9. I want to print all of them. How could I do that? What would I do? If you and I have an idea, feel free to put it into the chat. Yeah, Rachel is saying, let's use a for loop. And Akash is giving me what loop that might look like. I could say something like for I in range 10. And then instead of multiply 2 and 3, I'm going to indent this because it's inside of the for loop. Let's multiply 2 and I. So we're multiplying 2 times I, where I is going to range over all of these numbers. So now when I run Python multiplication.py, I now see 2 times 0, 2 times 1, 2 times 2, all the way up to 2 times 9. I'll pause here, give people a chance to ask questions if they have any. So again, the multiply function is serving the role of showing us what we get when we multiply two numbers. And then in the main function, we're using the loop to call that multiply function multiple times. Uzair is asking, why is this indentation important? Every indentation tells you what code is inside of some other programming piece. So everything indented inside of a function is inside of that function. This indentation is indented twice. That means this line of code is inside of this loop, which is inside of the function. So it's nested 2 layers deep inside of my code. And likewise, all of this code is indented inside the function once to mean it is inside of the function. Of course, we could change this 10, as a couple people are asking, if we wanted the limit to be something else. Right now, range 10 gives us all of the numbers from 0 through 9. It gives us 10 numbers starting at 0. And so it'll give you 0 through 9, which is why I start with 2 times 0, and I end with 2 times 9. But you could change that range to be a different value in order to get different values as well. But let's now try and make this more interesting. Now I don't want just my 2 times tables, but I want all of the times tables. I want 1 times everything, and 2 times everything, and 3 times everything, and 4 times everything. How could I do that? What might that look like? Yeah, people are saying use a second loop. In other words, use a nested loop. It turns out you can put a loop inside of another loop. If I have a loop that I want to run multiple times, I can put that loop in another loop. So let's try it. Inside of this loop for I in range 10, I'm going to add another loop for j in range 10. And now this loop, which is going to multiply I and j, this loop is going to itself run 10 times. And then we're going to go to the outer loop, and it's going to happen another 10 times. So we run this loop once when I is 0. Then we run this loop again when I is 1. Then we run the loop again when I is 2. And each time we run this inner loop, multiply is called 10 times. We're running the multiply function 10 times. So that in sum total, if we run the multiply function 10 times with this loop, but we do that 10 times in this outer loop, in total, we're going to get 100 different multiplications, 10 times 10. And so now if I run this, Python multiplication.py, now I get 0 times everything, then 1 times everything, 2 times everything, 3s, 4s, 5s, 6, all the way up to 9 times 9 equals 81. So this ability to have nested loops is often helpful if there is something you want to happen multiple times, but that thing itself you also want to be happening multiple times too. So with that in mind, let me give you one final exercise to work on today, and then we'll talk about it and do a few closing thoughts. But this last exercise is inspired by the game Super Mario, which maybe you've played before. And if you have, you might recall this grid of bricks that appears in one of the levels. Your goal is going to be to try to reproduce that grid. You're going to write a program that asks the user to type in a number n, and then you're going to print an n by n grid of hash marks. So a 5 by 5 grid would look like this, 5 rows where each row has 5 hash marks in it. Of course, if the user typed in 4, then you would do a 4 by 4 grid. So you'll have to think about how you're going to use loops. You might have to override what comes at the end of any print statement, for example. So you'll want to think about how it is you're going to solve this. I'll give you about 10 minutes to work on this. If you run into any trouble at all with this or any of the stuff we've been working on so far today, definitely ask a question on Ed, the course's discussion forum, which you can find here in the chat again. The mentors are here and are happy to help answer questions that you might have. But I will go ahead and give you 10 minutes or so to work on that. So let's go ahead and start a 10-minute timer, and we will see you in 10 minutes. All right, welcome back, everyone. Would anyone like to offer their approach to this? What were you thinking in terms of solving the problem? How did you go about solving the problem? Let's go to Arya Neil.
What I did was I prompted the user for the length, and then I did for I in range, and I did for length, and then I did another but for J in range, also for length, and then I would print the hashtags and n equals, and then I would print another.
All right, yeah, so I'm hearing two for loops where you have one for loop that's responsible for printing out each of the rows of this grid, and then within each row you want one for loop that's printing out each of the individual hash marks that compose that row. And so we can see one possible way that you might have solved the problem. I will share my IDE here. We might start by asking the user to type in the height. I'll just call the height n. So input n. And now we want to print n rows. So for I in range n. And what does it mean to print out a row? Well, it means we need to print out j hash marks for j in range n, print a hash mark with nothing at the end. That's very similar to what it is that we've been doing before in terms of printing out that bar chart of individual scores, for example. And then beneath that, we could just say print because we want to add a new line at the very end of it before we move on to the next line. And so something like this would have given you the effect of creating a n by n grid where you could get a 5 by 5 grid or a 4 by 4 grid or whatever value was provided by the user. So hopefully these examples today gave you an opportunity to get a sense for the types of things that you can accomplish with Python, the ability to use these loops and conditions to make decisions, to repeat code multiple times. And as we wrap up today's session on Python, we do actually have some optional homework for you. If you want to try your hand at writing some more Python programs yourself, getting some more practice with the ideas and concepts that we've been talking about today. So I'll show you what the homework assignments are if you'd like to participate in them. The first, also inspired by Mario. You might recall Mario in this level climbing this pyramid. And your first homework assignment is to build that pyramid. Write a program that asks the user to type in a number n, and then you'll print a pyramid of hash marks of that height. So a pyramid of height 5 would be 5 rows, where the first row has 1 hash mark, the second row has 2 hash marks, the third row has 3, 4, and then 5. Notice how everything is aligned on the right-hand side. Very similar to the grid that you just built, but a little bit more sophisticated. You'll have to think a little bit about how you're going to get everything to be lined up. Your second homework assignment is this problem called cash, to write a program that asks the user to type in any amount of money and print the minimum number of US coins required to make change for that amount of money. So in the United States, the standard coin denominations are 25 cents, 10 cents, 5 cents, and 1 cent. And so if I told you to make change for 31 cents, for example, you could use 31 pennies, but that would be quite a lot of coins. More efficient would be to use 1 quarter for 25 cents, 1 nickel for 5 additional cents, and then 1 penny for that final cent using only 3 coins. And so your goal is to write a program where I could type in 31 cents, for example, and your program would tell me 3 coins. That's all you need in order to do this. As a bit of a hint, when you're choosing which coin to use, you probably want to pick the biggest one you can. If you're making change for 31 cents, you might want to choose to make change for 25 cents first, rather than jump immediately to the pennies, for example. And so those we leave up to you to figure out how to implement in Python. And really, ultimately, we've only just scratched the surface in Python. If you go on to take CS50's, you'll end up completing these problems in Python as well as in C, and submitting these and others and learning more about Python and what the language does have to offer. And there are also other New Year's seminars that are coming up if there are other topics related to computer science you're interested in learning more about. So starting next week, I'll be leading one on SQL. Kareem from our team will be leading one about Linux, and then Colton will be leading one on game development. So if any of these are topics that are interesting to you and you'd like to get a little bit of a taste of what they're all about, we hope to see you at some of those future seminars too. But finally, before you leave, We'd love to get feedback on the session. We use that feedback to know what you liked and what we can do better in future sessions. So if you have a moment, go ahead and go to this URL here that I've just pasted into the chat, and I'll share it on screen too. It is cs50.ly/feedback. If you go to that URL, there's a very short form that you can fill out just to let us know what you thought of today's session, whether you enjoyed it, and any other comments you have for going forward into the future. But once you fill out that feedback form, that officially concludes today's session. A big thank you to all of you for being here, and a special thank you to all of our wonderful volunteer mentors who have volunteered their time to be here and to help answer your questions in the chat and to help you with your code as you've been working through it. So thank you to them as well. But thank you all so much. Hope you enjoyed this taste of Python, and we hope to see you at a future seminar.